Let me guess what happened the first time you opened a datasheet. You saw 300 pages, a bunch of tables, strange diagrams, and after about 10 seconds, you thought, nope, you closed it. Honestly, most beginners do. But here's the secret. Engineers don't actually read datasheets from page 1. We just hunt for the answers we need. And once you know where to look, these things stop being scary. In embedded systems, the datasheet is basically the source of truth. If your firmware depends on voltage levels, timing, current limits, the answer is always inside the datasheet. Whether you're using an ESP32, STM32, or Arduino class microcontroller, the datasheet tells you exactly how the chip behaves. So learning how to read one is basically learning how to think like an embedded engineer. The first thing to understand is this. Datasheets are not meant to be read like books. You don't start on page 1 and go all the way to the end. Instead, they're more like a reference manual. When engineers open a datasheet, we already have a question in mind. Something like, what voltage does this pin support? Or how fast can this interface run? And then we go straight to that section. So the first place I always look is the table of contents. And once you've seen a few datasheets, you'll notice something interesting. They all follow a similar structure. Overview. Pinout. Electrical characteristics. Peripherals. Timing diagrams. Once you recognize that pattern, navigating a datasheet becomes way easier. The overview section is basically the resume of the chip. It tells you the clock speed, how much flash memory it has, how much RAM, and what peripherals are available. At this stage, you're not studying details yet. You're just asking one question. Is this chip even capable of running my project? Next comes the pinout diagram. And yeah, the first time you see it, it looks like chaos. But it's actually pretty simple. Power pins, ground pins, and then a bunch of GPIO pins. Think of GPIO pins like programmable doors. Depending on the firmware, they can become input, output, SPI, I2, C, UART, whatever you need. Quick reminder, you still don't need to understand the entire datasheet. Nobody does. Now here's one section that engineers always check early. Absolute maximum ratings. This section basically tells you what will destroy the chip. If the max voltage is 3.6 volts and you feed it 5 volts, the chip may not survive. And the key word here is absolute. These are survival limits, not recommended operating values. Right after that, you'll usually see recommended operating conditions. This tells you where the chip behaves normally and reliably. Think of it this way. Absolute max keeps the chip alive. Recommended conditions keep it stable. Timing diagrams show how signals behave over time. Setup time, hold time, clock edges. If you've ever had an SPI or I2C device that just refuses to communicate, timing is often the reason. The chip expects signals in a certain order, within certain time windows. A lot of debugging in embedded systems comes down to this. Something violated the datasheet. Maybe the voltage was slightly wrong. Maybe the signal arrived too early. Maybe the pull-up resistor was incorrect. The firmware might be perfect, but if the hardware ignores the datasheet, things break. Imagine you're building a sensor node with an ESP32. Everything looks correct, but the board randomly resets. Eventually, you check the datasheet and realize your sensor is pushing a 5-volt signal into a 3.3-volt GPIO pin. That tiny mismatch is enough to cause problems. And that's exactly the kind of thing datasheets help you avoid. The most common beginner mistakes are actually pretty simple. Reading the datasheet from page 1. Ignoring absolute maximum ratings. Assuming every chip supports 5-volt logic. And not checking current limits. Once you avoid those, datasheets become way less intimidating. So here's the simple workflow engineers use. Start with the table of contents. Check the voltage limits. Look at electrical characteristics, then jump directly to the peripheral you're using. That's it. You don't read the entire datasheet, you just extract the information you need. Embedded systems isn't really about memorizing specs, it's about knowing where to look when you need an answer. If you're interested in learning how engineers actually build embedded systems step by step, you're in the right place. Subscribe if you want more videos like this, and I'll see you in the next build.